So here's problem 2 for week 3, and this is again going to be a static equilibrium and specifically a force equilibrium problem. So let's diagram out what we know. The weight of this ball is 200 pounds acting straight downward. And that means that the horizontal component of the tension in this wire rope has to also be 200 pounds. And because if you think about if you were to let go of this ball, it would swing to the right until it was hanging directly below point A. It means that some portion of the wire rope's tension's also got to be to the right. And we don't know that. We'll just label it X since it's in the X direction. Let's see what the problem's asking us to calculate. So to calculate the horizontal force F, which we've labeled as X, in order that cable AB to be inclined at an angle of 30 degrees from vertical. So this really is pretty straightforward. We know one quantity and we know an angle, and we're trying to find another. So think about our trigonometric functions. So, ka, toa. Well, what do we know? We know the adjacent side. So it's either tangent or cosine. And we're trying to find the opposite side. So the function that relates tangent and opposite, adjacent and opposite is tangent. So the tangent of 30 degrees equals what? Opposite over adjacent. X over 200. Now we multiply both sides by 200. And that will give us our answer. So 30, we're in degrees mode, take the tangent, multiply it by 200, and we get 115, which agrees with the answer that they give in the selected solutions. And you can think about this a couple of ways. 115 is reasonable because it's less than 200 pounds. It's less than the weight of the object. And for angles less than 45 degrees, we would expect the horizontal thrust to be less than the weight of the object. In fact, if you've taken a physics class, you may have at some point constructed an accelerometer, which is a very simple device. It's a protractor like you had when you were in elementary school, and you put a piece of string in the middle of it, and from that hung a washer. And then what would happen is, like, if you ran really fast as you were accelerating, this washer would be displaced opposite the direction of your motion. And based on the angle that it swung to, we could figure out what this force was. And based on this force, then we could determine the acceleration. Sometimes, like physics classes, go to Great America, and you'll take this instrument with you on a roller coaster, and you can make recordings in a very simple way of accelerations. We could figure out the tension in the cable. It's not required in the problem, but that would be as simple as 115 squared plus 200 squared, and then take the square root of that quantity. So again, there are a lot of things you can do with this. All they were looking for here was just the lateral thrust, which ended up being 200 pounds.